Hello there, this is Learn with Ceri. Well, there you go. You've completed all the quests for stage 1. Congratulations, everyone. I've chosen a couple of questions to go through. Monsters on the stairs, some neat algebra on question 8, and question 9 and question 10 were quite quick if you had the correct method. So let's see those too. The monsters question. A staircase has 15 stairs numbered from 1 to 15, with stair 1 at the bottom and stair 15 at the top. There are 15 monsters who climb the stairs. Monster 1 steps on every stair. Monster 2 with longer legs starts on stair 2 and skips 1 stair with every step. Monster 3 starts on stair 3 and skips 2 stairs with every step. And this continues until Monster 15 only steps on stair 15. Some stairs get stepped on more than once. Example, step 4 gets stepped on by monsters 2, 4 and 1. Stair 1 will only get stepped on by monster 1. The monsters climb the stairs in order from 1 to 15. What is the number of the first stair that gets stepped on 6 times? So much information. So here's a little picture of some stairs, 15 stairs. And then I decided I needed a table. So I've got monster 1 stepping on every single stair. Monster 2 would step on stair 2, 4, 6, 8, 10, 12, 14. So let's keep a little note there. All the even stairs. And then monster 3 is going to step on all of the 3 times table numbers. 3, skip 2, 6, skip 2, 9, skip 2, skip 2, stands on 15. Okay, let's have a look at monster 4. 4, 8, 12, 16 is not 1. So let's look at monster 5, steps on 5, 10, 15. Monster 6 steps on 6, 12, 18. Monster 7 on 7 and 14. And then monster 8 is only going to step on 8. And then 16, so all of these actually don't even get a second step. Monster 8, 9, 10, 11, etc. They only stand on 1 stair. So we can have a look now and see which one has got the most on it. So that would be number 12. Number 12's already had 1, 2, 3, 4, 5 monsters standing on it. So we can say that monster number 12 would then stand on it, making it the 6th one. So actually, stair 12 is the answer, but actually it's the only one that gets stepped on 6 times. And there you go. So we've got a lovely algebraic fraction here, and it simplifies to ax squared plus bx plus c, and we have to work out the value of a plus b plus c. So when we look more closely here, we've got negative powers, and negative powers are reciprocals. So let's rewrite that 3 bracket x plus 1 to the power negative 1. The power only applies to the bracket, so we've got 3 divided by x plus 1, and then similar for the next term, the 4, and then it's over x squared because it's a power of negative 2. And then all of that is over 1 over x cubed plus x squared. Now, when you divide by a fraction, this big divide I mean now, when you divide by a fraction, you multiply by its reciprocal. So I'm just going to rewrite this as a multiplication. So all of that top numerator there multiplied by x cubed plus x squared. Right, now let's have a look at this fraction and these 2 fractions in the bracket. They need to be added. So our denominator is going to be the product of those 2. So we've got x squared, x plus 1. And on the numerator, the 3 gets multiplied by the x squared and the 4 gets multiplied by x plus 1. And all of that has to be multiplied by x cubed plus x squared. Now, maybe you're jumping ahead already and noticing that this denominator is equal to this multiplier here, because when you expand this bracket here, you get x cubed plus x squared. So that whole denominator cancels with this multiplier, And if we then tidy up the numerator, we've got the right format, because we've got 3x squared and then a plus 4x plus 4. We've got our ABC now. And the last step is simply to do 3 add 4 add 4. So the answer we need to submit is 11. There you go. Wasn't as bad as it looked. Let's have a look at question 9. On a number line, the fraction a over b is 5/4 of the way from 5/8 to 7/4. If a over b is in its simplest form, what is the value of a plus b? Okay, let's have a look. Let's have a quick sketch. So we've got a value of 5/8, and then we've got a value of 7/4 somewhere else further along the line, and we could think of that as 14/8. And we've got to go 5/4 of the way along, which is past it, because 5/4 is greater than a whole, so we're going to go the whole and an extra quarter along. So we're looking for some value over here. Right, so let's have a look. What is 5/4 of that difference? So we want 5/4 multiplied by the difference between 7/4 and 5/8. Okay, so 5/4 multiplied by, now if we do change, like I suggested just before, change this to 14/8, then we get 14 take away 5 makes 9/8. So we get 5/4 multiplied by 9/8, which is 45/32. Now that's the size of that green distance that we're going to add on to 5/8. So now we need to go back to our 5/8 and add on that new value of 45/32. And I'm going to change this fraction here to also be over 32 by multiplying the top and bottom by 4. And that gives me a grand total of 65/32. Now, 65/32, they don't have any common factors, because with 32 it's 2, 4, 8, so no. So that is our a over b. So the final answer to input to the system is 65 plus 32, which is 97. So that's the answer we were looking for, guys. And then finally, question 10. In the diagram below, a square with side length 20, so the total square length 20, is divided into 4 congruent rectangles and a square with a length of 6. Okay, so let's make it absolutely clear that all the way across is 20 and just this little length here is 6. What's the area of one of the rectangles? So if we do the large squares area and take off that central squares area, the area we're left with has to be split equally between the 4 congruent rectangles. So that's what we need to do. We need to do 400, take away 36, and then divide by 4. So we end up with 364 divided by 4. 364 divided by 4 is 91. There you go. There's your answer for question 10. And that's it for this week, guys. I really hope to see you at stage 2. But bye-bye for now.